Hey everyone, today I'm continuing on my system design primer and we're going into part two, which is system characteristics. So, system characteristics are pretty important because when you're designing a system in a system design interview, you need to design your system in a way that they have these specific characteristics or attributes. So, the first one is scalability. When you're designing a system in a system design interview, you want to keep in mind if this thing is scalable or not. And what exactly does that mean? So, the definition of scalability is the capability of your system to grow and manage with increased demand. So, in simple terms, a scalable system can expand or adjust resources to handle growth in the workload of the system without compromising performance. So, I'll give an example here. Consider a social media platform. You need this platform to be scalable. So, if there's peak hours where the traffic just spikes like crazy, or in another case, like you're a startup that's that's in like the hyper growth phase where you're getting like 1 million new users a week. How does your system scale as like traffic spikes or you get a ton of users? So yeah, when you're designing your system, you need to be thinking about that. And pretty much the two main ways to make your system scalable is first vertical scaling. So this is kind of like the more simple one that everyone knows is, so pretend I have a server and I just have a 1 million new users being served. Like I have a server that's hosting Facebook and I just have 1 million new users. What I could do is just add more power to that server. I can make the CPU stronger. I could add more RAM. I could just like beef up that machine, and that's called scaling up. But basically, we're limited by hardware constraints there. Pretty much, like the best you can do is like turn it into a supercomputer, and supercomputers is super hard to maintain, and parts are very expensive. So what a lot of these cloud companies or just regular software as a service companies do is instead of vertically scaling, which is just like making their machines stronger, they add more machines, so they scale horizontally. So instead of one server um, just serving all the requests for Facebook, let's have two servers, and and we'll just like round robin it. You go to that server, your brother goes to that server, your sister goes to this server, and it's just like spreading the load between multiple um, less powerful machines. So that's one way you can do that, and you could pretty much scale horizontally for forever. Obviously, it involves some coordination now. Now you have to coordinate all these different nodes, but it's a lot more scalable than just like continuing putting more CPU, more RAM, and because like as you know, like if you add 500 gigabytes of RAM to your computer, like it doesn't really make things that much. Like there's a limit that gets reached there. So yeah, that's scalability. The next the next system characteristic is reliability. So reliability is the ability of a system to continue operating correctly and delivering services even when there's faults, errors, or partial failures. So the key principles of reliability are removing single points of failure. So your system should be designed so that the failure of a single component doesn't bring down the entire service. I think that's pretty simple. It's just like having a backup. So pretend you have one server and it just goes down. Now no one could access your application. So fault tolerance would be like having a backup so that they can like pull from the backup instead of like just having one single point of failure. So that's reliability. Automated failover, that's pretty much just like similar to what I mentioned where if something goes down, it just automatically fails over to the next thing. So if one server goes down and everyone's using that, it automatically just starts pushing everyone to the other server. And then another key thing with reliability is data persistence. So that's just making sure that data is persisted. So like no one likes to lose their data. Imagine I posted something on Instagram and I just like it goes I lose it when the server goes down. Data persistence just involves like that. It also involves having multiple points of failure. So a lot of times will be like a lot of your data is copied over multiple servers. So if one server goes down or just gets destroyed completely, another server still has like your data there. So yeah, I think reliability, the key thing to just make sure you understand is to when you're building a system is to not have single points of failure. I think interviews will push on that a lot because you don't want your like right now a big thing is availability, and that's this third characteristic that we'll get into here. So availability is pretty much the measure, it measures the proportion of time a system remains operational under normal conditions. So it's usually expressed as a percentage, and a lot of people in the industry just call it uptime. So, like for example, Facebook, for example, might be like 98% uptime. That means 98% of the time that you go into Facebook, you'll be able to access Facebook. So you don't like you want to build a system that's mostly available. Like of course things will go down, but you need to make sure that it's available most of the time because um, especially if it's a critical service, because if it's a critical service and it goes down, people can't use it. For example, like emergency 911, they're designed to work near 100% uptime, even like because if they have any downtime at all, it's severe consequences. So, but yeah, like most software, like if Facebook probably could get away with 98%, if it was around 95%, like people get annoyed that they're trying to access Facebook because there's lots of people that go ham on Facebook and just use it like crazy. So, balancing reliability and reliability kind of implies availability. You can achieve a lot of availability using like fault tolerance. That's basically what it's saying there. Um, Availability without reliability. A system can technically be available by, so basically it's saying reliability kind of implies availability, but not the reverse. You can be available without being reliable. But I don't think that's that important. I would just say just when you're building a system, make sure that you're thinking about availability, and a lot of times that involves making your system reliable. So those kind of go together. Efficiency. This so the first characteristics pretty much just involve just like how your system um yeah, let's get into efficiency. I was gonna say something there, but that probably didn't make it probably wouldn't have made sense. So, the definition of efficiency is measuring how well a system performs under various loads. Uh, Efficiency pretty much focuses on latency and throughput. So, latency is pretty much the time taken to process a single request or transaction. So, for example, if I have a news feed, the latency will be pretty much like when I ask for the news feed, how long will it take for that news feed to get back to me? If the latency is really high, I'll see like a spinner for a long time, and users do not like that. So, you need to figure out a way to make latency as low as possible because these days users kind of expect the apps to load very quick. So that's what latency is. Um, Sorry, let me just mute my Discord. Throughput. Throughput is the number of requests or operations a system can handle within a specific time frame. So throughput is like latency is like how fast it comes. Throughput is more on like the server side. So if I have a server, uh, like how many news feeds can I service in the span of like 1 second? That's my throughput. If I could say I could give back 1,000 news feeds in the span of 1 second, that's my throughput. And then obviously you want a high throughput system. You want to be able to like service as much news feeds as possible at like given a time frame. But there's like trade-offs there. And then lastly, let's get into serviceability and manageability. So serviceability and manageability is more like what happens after your system is built. So if you if you think of like this analogy of a car, after like system design would just be like figuring out how the car works or just like building the car. But then after you have a car, you want a car, you don't want just a supercar that like works really well and then you take it to the shop and you cannot get it serviced and then you cannot figure out what's wrong with it. So serviceability and manageability is kind of like that's the analogy I would use. So Think of a car designed with ease of maintenance in mind. A highly serviceable car allows mechanics or even the driver to quickly identify issues, perform repairs, and then get back on the road with minimal hassle. The easier it is to maintain, the more reliable it will stay operational and ready to use. And that's also very important with a system that you build. You don't want to build such a complicated system that no one will be able to fix it. Like it might work perfectly, but the moment it goes down, it's just down for forever because no one knows how to fix it. And then also no one knows how to manage it. Like you never know what's wrong with it. So the key aspects of a serviceable system is monitoring and logging. So your system should have detailed logs and active monitoring that can help you identify issues really quickly. So think about a car; those are just those lights that pop up, like when you have low tire, when you need oil change. That's like the monitoring and logging, and then yeah, um, automated scaling deployment. I don't think those are important. I think the main thing with serviceability and manageability is just thinking about like my system and just thinking about like, okay, if I had to give this to someone else and they had to run with it and I was out of office, how easy would them to be able to run it? How easy would them to fix it and things like that. So you want to design a system that's easily serviceable and easily manageable. And yeah, that kind of covers the system characteristics that I care about and that I'm thinking about when I'm designing a system. And I'll see y'all in the next video.